Hey everybody, welcome back to the channel. It's been some time since I posted last and I had to apologize. It's been quite a busy time. This video, I am actually going to pivot from the code book for this one and just go back to some basics. And let's do some basic DC theory and let's look at series circuit calculations. So on the screen here, I have a simple series circuit with 4 resistors and a meter. To the left, I have the great wheel of power for calculating Ohm's Law. And below that, I have our series circuit rules. And before I get into those, to the right, we also have our resistor color code chart for interpreting the color bands on a resistor, carbon resistors. Okay. Maybe in a future video, I'll do a video on how we use this chart for those that are rusty with it or unfamiliar. It's really not that complicated. But let's look at the series circuit rules. All right. So I have 4 rules listed here. They're very basic. They're very simple. If you follow these rules, you can solve any series circuit. Okay. So our first rule here says the sum of all voltage drops must equal the source. You see that in the formula? Basically, the total voltage equals the voltage you see at point 1 plus the voltage you would see at point 2 plus the voltage you'd see at point 3 plus the voltage you see at point 4 and so on, whatever number you have. So if you look at this circuit here, the series circuit, the total voltage is going to equal the voltage you would see at all 4 points added up together. Okay, so we add all these voltages up at each point, we would know the total voltage. Okay. Next rule I have is current is the same at any point in a series circuit. So in a formula form, algebraic form, IT equals I1 equals I2 equals I3 equals I4 equals however many resistors you have. And it makes total sense. Let me show you why. All right. You got the series circuit, and we're thinking conventional current flow from positive to negative, right? Current is leaving the source and it's taking this path. Now, this is the only path it can take. Mind you, yes, I have a voltmeter in here. How do I know it's a voltmeter? Because I'm in parallel to a load, right? Voltmeters go in parallel. They're measuring the potential difference between 2 points. If this meter was in series, then it'd be an ammeter because we'd want to measure all the current in the circuit. So we need all of that current to go through the ammeter. You should pay very close attention to that. Now, the clamp-on meters, okay, yeah, sure, you can clamp it around the wire. But for a DMM with meter leads, you have to break the circuit and get that meter in series with your circuit in order to measure the current. Okay? Never hook your ammeter up in parallel. Ammeters have very low resistance. You're going to blow your fuses right away. All right? Anyways, back to the series circuit. Yeah, electrons, there's nowhere else to go. Again, assuming that, sure, a little bit will go through here, but just as a series circuit, ignoring this voltmeter, there's no other path to go. Okay, so whatever current you see at the resistor 1, resistor 2, 3, or 4, it's going to be the same. Nothing's going to change as far as current. Okay, so IT equals I1 equals I2 equals I3 and so on. Now, the total resistance of a series circuit equals the sum of all resistance in the circuit. So algebraically, RT equals R1 plus R2 plus R3 plus R4. So you would add all these resistor values up, and then you would get the total resistance of this series circuit. Okay, so the sum of all these resistors in a series circuit will give you the total resistance. And then the last one, we're dealing with power. Total power of a series circuit equals the sum of all power at each load in the circuit. So very much like voltage and resistance, you just add up all the power values that you calculate at each point. You add all those up and you're going to get the total power of that circuit. Okay, so let's solve this puzzle. I like to call them puzzles because that's all they are. Okay. Now, there's not really any information anywhere on here. I'm looking for voltage, current, resistance, and power at every single point, including the total. Okay? The only thing I know is the voltage at resistor 2, right? So I could actually just fill that in right now. I know that E2 equals 3.96 volts, but that's about it, except for I have color bands on my resistors. Those can tell me the resistor value when I reference this chart over here. See if I can get that clicked. There we go. Just going to drag it over for now. Again, it's a little blurry. If you want a sharper one, you can find them all online. I'm not sure why this one did not come out clear, but we'll make do with it. Okay, so again, this video is not on how to decode a resistor. I can do another video on that if you want to comment and you need to have a video like that. I can do one. Just let me know if that's something you'd like to see. I can do a bunch of examples with that as well. And as well, there's a lot of great videos out there besides mine that can show you how to do this or resistor color code interpretation. But I would like to think that mine is the better video. Okay, so again, it's not on how we use this, so we're going to do this a little quickly here just to get the values we need so that we can solve the missing values for this series circuit. So if I'm looking at resistor 1, I have a brown, black, black. Okay, so I'm going to switch my pen color here just to be common black. So I have brown. So my first color band, brown equals a 1. So I know I have a 1. Make that a little bigger. My second one is black. Black represents a 0. And then I have my multiplier band. Now, I'm not sure how you guys have been shown if you know how to do this. Here it kind of tells you how to multiply by, but the easiest way to do this is, okay, black represents 0. That means I don't add any more zeros to my first combined numbers here, my first two combined numbers. Example, if I had brown, brown, red, then, well, let's just draw it out. If I had brown, brown, red, let's see if I got that up here still. I don't have, let's just do instead of brown, because I don't have a brown showing up. Nah, we'll leave it. We'll use this color here as our brown. Okay, so that's my last. I have a brown, and then I have, we'll say black. But now my last color is going to be red. Well, then that would represent, go back to black. If that was my color code, then I'd have a 1. I'd have a 0. And then red represents a 2. So I would just add 2 zeros, and that would have been a 1,000 ohm resistor. Right? But for ours, we are a black or brown, black, black. All right, so just 10 ohms. So now I can throw that in here. R1 equals 10 ohms. And I would like to use a different color. So 10 ohms. Okay, next one. We have yellow, yellow, black. Well, yellows represent 4. So I know I have a 4, 4. And then my multiplier is black, which represents 0. So I will add no zeros after those first two numbers. This equals 44 ohms. R3 is a red, violet, black. Well, I have a 2. Kind of hard to see. Violet is 7. Black is 0. I'm not adding any more numbers, any more zeros to this. So R3 is 27 ohms. And then R4 is a yellow, black, black. Yellow is a 4. Black is a 0. But the multiplier is also black, which represents 0. So I'll add no more zeros. This one is 40 ohms. Okay, so that was a quick way of interpreting our color codes. I'm going to slide this back over because I may need the room. Okay, now we can do some Ohm's Law, because with Ohm's Law, you need at least 2 values to be able to do it. And before we even do that, we could actually find RT. We could find RT because, one of the rules for a series circuit is RT equals the sum of all resistor points. So RT equals R1 plus R2 plus R3 plus R4. All right, so we got 10 plus 44 plus 27 plus 40. I am going to use my calculator because I don't want to do a typo, and I'm tired. We get 121 ohms. So our total resistance is 121 ohms. That was our first step. Now we could have solved I2 and P2 as our first couple steps. That's fine. Doesn't matter. I just decided to get this out of the way. RT. Now we know that. Okay. Now there's nothing else we can do except resistor 2. There's no two values at 3. We don't have two values at 4 or at 1 or even the totals. We have to start here. Okay. So step 2 for me is going to be, let's find I2. Okay, so the current at resistor 2 is going to be equal to the voltage at R2 divided by the resistance, right? I equals E divided by R. Okay, that is just your Ohm's Law formula. Let's bring this over, right? If you want to find current, I use the letter E, but same thing, V divided by R will give you current. Okay, so back to this. Fill in the numbers. So we know we have 3.96 volts divided by the resistor value. And if we calculate that, it's not going to be very big. 3.96 divided by 44 gives me 90 milliamps. 90 milliamps, which is 0.09 amps. Okay, cool. Let's fill that in. I'm going to make this larger because I don't want to print that small. 90 milliamps. Why am I filling this in everywhere? Well, if you remember, series circuit rule for current is the same at every point in the circuit. Right? So once I calculated I2, and I know there's 90 milliamps there, then 90 milliamps is going to be flowing through here, and it's going to be flowing through here, and it's going to be coming from the power supply and flowing through resistor 1. It's like a one-way street. There's no way around it. Okay, so 90 milliamps is flowing through my series circuit at all points. So once I solve the one, the rest I just fill in. Because again, I'll just say IT equals I1 equals I2 equals I3 equals I4. And we knew I3, therefore they equal that one, that one, that one, and that one. They're all the same. Okay. So now we have two values at every point. It doesn't matter what you knock off. Now at this point, it is just Ohm's Law. So you know what? Let's just finish off P2. Let's just do that one. So I'm going to go step 3. And I'm going to find power at resistor 2. So power equals the current at that resistor times the voltage at that resistor. Now you may see as power equals V times I. Or E times I. I like power equals I times E because it spells pi, and I like pi. Meaning apple pie, pumpkin pie, all that pie. Right? And it's just easy to remember that way. Other than that, fill in the numbers. Let's see what we get. So 0.09 times 3.96. We get 356 milliwatts. Okay. Now, one thing I want to caution you on is this number here, we calculated that. Or no, sorry, not that number. We calculated the current. We calculated current here. Now, we used that calculated value in this formula. If this number was wrong, if our current was wrong, that's going to make this wrong. You have to be very careful when you're using your calculated values and formulas. Whenever you can, always use the given values that you know. All right? Always use those. But when you're using your numbers, you better hope they were correct, or else it's going to throw everything else off. All right, so we solved all that. It doesn't matter where we go around the puzzle. Let's just go back to E1. Let's just knock that one off. Let's start back at the beginning. Let's go blue. Step 4. So E1, again, the 1 just means what point in the circuit I'm at. It's still going to be E equals I times R, just dealing with the first point. 0.09 times the resistor value. Let's clean that up. 10 ohms gives you 0.9 volts. I better double check that. I know it's pretty obvious, but I need to double check. It's just getting to be a long day. 10 times 0.09. Yes. So 0.9 volts, which is also equal to 900 millivolts. Okay? So 900 millivolts. And then let's do another color for step 5. Step 5. Let's find the power at that resistor. So power at resistor 1 equals current times the voltage. Okay. Now we're dealing with 2 numbers we calculated. See how this could go really wrong if you don't have your numbers right. 0.9 equals, so 0.9 times decimal 0.9 equals 81 milliwatts, which is 0.081 watts. Did I get that on there? Or did the screen? Oh, how'd that happen? There we go. Okay. Milliwatts. Okay. So, 81 milliwatts. That's good. Let's go down to 0.3. Let's pick a color that's a little easier to see maybe. How about this blue? Steps. Oh, that's the same blue that we already used. I just like to have contrast here so you guys can follow along better. Let's go with the orange. All right, step 6. Step 6, well, let's find the voltage at resistor 3. E equals I times R. 0.09 times the resistor value that we found to be 27 ohms. We're going to get 2.43 volts. 2.43 volts. Cool. 2.43 volts. And now we got power 3 to do. Let's go with a green. Doesn't mean any color here. Step 7. So power at resistor 3 equals the current going through it times the voltage drop across that resistor. 0.09 times 2.43. We get 219 milliwatts. If I round up. Oops, not volts, milliwatts. Okay, which is 0.219 watts. Okay, 219 milliwatts. All right, E4. Actually, I'm going to show you something. I'm going to skip E4. Let's go to ET. Let's finish off ET here. Let's show you a little something. Purple. I haven't done purple, I don't think. So let's go down to step 8. Okay, let's find ET. Same formula. So the total voltage is going to equal the total current times the total resistance of the circuit. All right, so we know we have 0.09 or 90 milliamps times the total resistance of 121. Okay, 121 times 0.09 equals 10.89 volts. Okay, so 10.89. Cool. And then we can just do power over here. I'm going to shuffle this around so we get more room. Like that. Different color. Let's go with this yellow. Hopefully we can see it. That's the only thing. Step 9. I guess you can see it okay. Step 9 is find the total power of this circuit by using the total current times the total voltage equals 0.09 times 10.89. You get 980 milliwatts. Okay, zoom in on that so I can see it. Okay, another way you could have done it was I squared R. We could have found power by I squared R, I believe. So yeah, I squared R. So you could have went 0.09 squared times 121, and you get the same answer. So if you wanted to try that just to see, it's just 0.09 squared, which is basically 0.09 times 0.09. That answer times 121, you'll get the same thing, 980 milliwatts. Okay, I wanted to, actually I'm going to do it for P4. Let's do that. Let's do that formula. It's sometimes good just to change it up so you're just not stuck in your head with the same old formulas. It's good to use different formulas just for practicing here. So step 10, let's find P4 by using I squared R. So I squared times resistor, right? So that's going to be 0.09 squared times 121. Let's see what that comes out to. 0.9 squared times, actually times 40, my bad. Good thing I caught that. So let me back this up before you put the answer in. Times 40, because we're looking at 0.4, right? So you calculate that. The answer is 324 milliwatts, or 0.324 if you prefer. Okay, 324 milliwatts. Now, I wanted to leave this for a purpose. So you know, series circuit rule says the total voltage equals the sum of all voltage drops. So, okay, we're in this case here. We actually know this, the total voltage, and we know all the voltage drops except one of them out in the circuit here. That's okay. We can just do this then. Let's go. Let's pick some other color here that's never been used. Let's see how this looks. Okay, we can find E4. So let's put a new step in here. Step 11. E4 is going to equal ET minus the sum of all our voltage drops that we do know. Right? So 10.89 minus the sum of 0.9 plus 3.96 plus 2.43. Okay, equals 10.89 minus, and I got to add this up for you guys, 0.9 plus 3.96 plus 2.43, 7.29. So now 10.89 minus 7.29 equals 3.6 volts. Get on there. Okay, 3.6 volts. We can verify that just by doing some Ohm's law. Let's do I times R. So 0.09 times 40 gives you 3.6 volts. All right, so that is basically it. That's how you do a simple series circuit. Let me know what you think. Let me know if you want some other videos like this. I think I mentioned at the beginning, I am possibly going to change the title of this channel because I want to include more theory calculations like this, not just code, but I want to have a section on code, some videos on this theory, and I also want to do some videos on controls and automation. I do a lot of that for a living, a lot of controls and automation as well. So I think it'd be good to put some content out for that. Let me know what you think. I hope you like this video. Hope to hear from you soon in the comments, and I'll try and get more videos out soon. Thank you.